All right, so hopefully you can see this. Welcome back to Ice Cubed video. Yeah, I'm a nerd. You guys know that though. Let me hit the focus and see if we can get that in any better. All right, so we're going to be focusing on finding the composition of functions with rational functions. But first we need to practice finding the common denominator. So if you saw something like this, I can't combine the 2 over x and the negative x over 1 unless I find a common denominator. Well, my only denominator is x, so I'm going to multiply 1 by x over x, which gives me 2 over x minus x over x. And now if I was to combine that into one fraction, I would get 2 minus x all over x. So take a moment, maybe pause, and then you guys can take notes on it, and then we're going to use what we just learned in finding the composition of functions, of 2 different functions. All right. So here are our functions today. F of x is 3x over x minus 1, and g of x equals 2 over x. And since we're going to be finding the new domains, we want to look at what our domains are originally. So in the case of f of x, we know that x cannot equal 1 because that would make my denominator 0. And in the case of g of x, we know that x cannot equal 0. Otherwise, it's all real numbers except for those. And I'm not going to write them in interval notation right now. So first we want to focus on finding f of g of x, where g is my input to x. So f of g of x is the same as f, where the whole function g is my input into f, which really becomes f of 2 over x. Now here's where things get kind of tricky. So wherever I see x, I need to replace it with 2 over x. So I'm going to have small fraction bars and larger fraction bars to denote my original numerator and my original denominator. So in my original numerator, I'm going to have 3 times 2 over x, big fraction bar, all over 2 over x minus 1. And we can simplify that to be 6 over x on top, big fraction bar. And remember, we just found the common denominator on the other side for this. We said it was 2 minus x all over x. So 2 minus x all over x. Now, to simplify this, when we divide one fraction by another fraction, maybe you remember we take the reciprocal of the bottom fraction and multiply it by the top. So this becomes 6 over x times x all over 2 minus x. In this case, I get 6x all over x times 2 minus x. And I'm going to want to simplify as much as possible. So I'm going to get rid of the x on top and the x on the bottom. And I can say f of g of x equals 6 all over 2 minus x. Now, new domain. Remember, new domain. 2 important points. 1, the input domain. And my input domain, in this case, was function g, so x cannot equal 0. And then the final is, or the final domain is also important. So at this point, you're going to want to ask yourself, what can x not equal in my final new function? And x cannot equal 2. So my new domain, if I put it in function notation, is x is a set of negative infinity to 0, or 0 to 2, or 2, oops, that should be a parentheses, to infinity. All right, here's this whole problem 1. At this point, you might want to pause and take notes before we look at the next page or next problem. All right, so we also said up here we wanted to find g of f of x and its new domain. So g of f of x is where I input function f into g. So g and function f is 3x all over x minus 1. So now in function g, wherever I see x, I'm going to replace it with 3x minus 1. So in this case, I get 2 big fraction bar all over 3x little fraction bar x minus 1. Now we need to realize this is really the same as 2 over 1 divided by 3x all over x minus 1. And it's 2 fractions divided by each other, so I want to take the reciprocal of the denominator and multiply it. So in this case, 2 over 1 times x minus 1 all over 3x. And now, if I distribute my 2, I'm going to get 2x minus 2 all over 3x. So I can say that g of f of x is 2x minus 2 all over 3x. Now what's my new domain? Maybe you want to pause this and see if you can come up with it on your own. But my input domain on this time, x cannot equal 1. And my output domain, what would make the denominator 0 for my final function would be 0. So x cannot equal 0. So in this case, it looks very much like the one on top. That should be a u, or 0 to 2, or 2 to infinity. Now remember, I have office hours at 12 to 1 on Wednesdays, so you can feel free to pop in for that, or you can schedule some other time and we can go over this together.